Ronnie, did I give you enough information?
You're going to continue it on the show. Are we on, sir?
You are on.
We're on. Oh my God. Good morning. Well, it could be any time of day, but we're in the morning, still 11 o'clock, ladies and gents, astro freaks. We have covered some pretty amazing stuff on this show, and this week may be no exception. Be prepared to be awestruck by the cosmos as we present the SBAU Astro Hour. I'm your proud host, Ronnie Herron, with my friends from the Santa Barbara Astronomical Unit gathered on the Zoom screen with me. I'll introduce them to you in a moment. This will be our 220th program edition of the SBAU Astro Hour for May 19th through the 26th, 2025. This week we'll be covering, oh my gosh, our planetary positions of the solar system, our siblings out there, rounding up the usual suspects in the night sky. Couple of great photos to share this week. One, a close-up of Saturn's A ring and one of its shepherd moonlets called Daphnis from Cassini. And the other is a shot of a solar flare that looks like a hummingbird catching a mosquito. Kid you not. And we continue our definitive look at galaxies, including the Markarian's chain out in the Virgo cluster, plus spirals, ellipticals, irregulars, peculiar galaxies, and the life cycle of a star. To see past shows or watch them live or watch us live, like some of the people out in President Jerry's Homeowners Association, we welcome you guys aboard. Just sign into youtube.com. Join us in the general meetings on the first Fridays and monthly star parties in the beautiful SBA Museum of Natural History. We also have some amazing outreach events. SBAU.org. Let's meet the crowd, the crew that's on the screen once again. Commander of our starship is Jerry Wilson, beloved President Jerry.
Good morning, and good morning, Joyce.
What? What'd you say?
I said good morning, Joyce. My sister usually watches from Pasadena.
You're a pretty good speaker, yeah. And I assume all the wives watch us or at least support us. And those people now know a little bit more about the astronomy, the cosmos out at your homeowners. Pat Forgy is his beloved wife, and he's only been in office, 7 or 8 years. Chuck McPartland's been out there at the club for many years as our outreach coordinator. He's married to a Pat. She's also a merchandise manager and one of the best treasurers we've ever had. No offense to Colin Taylor. Tom Whittemore joined us. He's married to Maureen.
Morning.
Tom edits our newsletter and spent many years in a great science lab out at Westmont College. Tim Crawford joined us. He's married to a lovely Karen, resident lens and telescope expert. Did you not go out to Westmont Friday night because you got our outreach guys notice? Were you planning on going, Tim?
I didn't go. I kind of regret it because my hunch was right. It cleared up at 8.
Well, I was asking our outreach guy, do you love those nights when it's canceled and you don't have to lug around the heavy equipment and telescopes? And he went anyway. And there were how many people, Chuck?
Just 9.
9?
We left the message saying that the event was canceled because Jen had some things for her students.
Get a little cloudy.
Yeah.
Yeah. I looked up and saw, yeah, they're right. It's going to cloud over, May gray. And son of a gun of Bruce Murdoch's not joining us. Longtime supporter, telescope enthusiast, acting as a professor to me, teaching me about logarithms. And his wife is Bonnie. And also, if you ever want to hear that incredible pipe organ down at the Arlington, he's the man in charge of the SB Theater Organ Society. We also start every show.
Yes. Before you get off that subject, we have an open console every month, typically the second Saturday. And anybody can come down and play it, listen to it. We'll take you through the chambers, and it's open to the public. It's free.
You know what you should do? You should try to move that to the museum on the second Saturday. That'd be an awesome viewing of this cosmos, wouldn't it? Here's some Haydn well, let's see, who besides Bach was good on the organ? They all were, weren't they? Mozart?
Oh, Handel. Yeah, there were a lot of them.
Yeah.
What's the beauty?
Well, the guys want it dark and they probably want it quiet too, I would imagine. Especially if they're doing their pet rock thing. It's just amazing what you guys will see when you go to second Saturday star parties. So thank you. Let's go to the screen for the sillies and see if they match what I received from President Jerry, our silly science cartoons. and some definite thought provokers.
Your comment to Bruce about him teaching you logarithms reminded me of an old cartoon that I saw in college, and it showed this four-piece combo, jazz combo, and they're playing their instruments on a log floating down the river.
Well, I get it confused with algorithm. They have nothing in common except for the word rhythm. You suppose there's some common denominator there with ancient Greek or Latin? I have no idea.
Greek.
All right, here comes the sillies. This is very interesting. All the land, space without the space, land areas only, crammed together, sort of like the Pangea of the solar system. I was worried about Titan, which is a lot of lakes full of methane, but there it is in the upper right. These are to scale. Venus is all land, isn't it?
Yeah, and it's the same size as the Earth. So the area of this thing up here with our map superimposed on it and Venus should be about the same. But it's so irregular, you don't get that. It's not easy to see.
I can't find Earth. Where is it?
Where?
Right in the middle.
Oh, it's not, doesn't have a name on it. Yeah, that's all.
No,
Really?
it's
Are you
got
that
our,
much? Oh, I see it. Okay.
yeah.
Well, they included the oceans.
Yeah.
Yeah, there they did, because under the water is the surface.
Oh,
So land under the water.
we're pretty much convinced that Mars used to have water, aren't we?
Pretty much, yeah.
Because
Still
there's a lot
does.
of,
It's got obvious flow patterns on the surface.
is it possible there could be life there that's now fossilized as microbes?
Boy,
It's
that's the $64,000 question, isn't it?
It's possible there is life underground there. Yeah.
Even still, without water.
No,
Well,
they have
there is
water.
there's water
There's plenty of
underground,
water,
but
Ron.
Yeah.
Yeah, but it's all frozen. You can't drink frozen
No,
water.
it melts occasionally in the spring, especially when it's mixed with salt.
All right. Well, that's why I'm here to ask the stupid questions and get a good at. Here we go. Fantasies of a cat, a feline, as it hops into its space. Well, what is it doing? It's jetting out into space. Okay, there it goes.
Squeezing into its box.
And it comes back to, you really love that box. Yeah, it's my spaceship. You're a
You've
cat.
had cats, haven't you, Ron?
Yes, I have. I love cats.
So
As
you
much
know
as
they
you
go
can.
right for open boxes.
Yeah, they do. Anything that'll hide them.
Yeah.
Sometimes they'll climb up in an engine of a car and get stuck. Okay, this was interesting. I wondered if this was Peanuts. Charles
No,
Schultz.
it's in that
probably not.
style.
Okay, this would be the. Anyways, I guess the doggy is propelling her using a large slingshot at the moon, and she
Yeah.
ended up. But she says it appears to have landed on the dark side. Darn it,
It
again.
crashed, can't see anything, so it must be the dark side of the moon.
Reminds me of that early silent movie From the Earth to the Moon. Remember where the moon has an eye and it got hit?
Oh yeah, got a big rocket ship stuck in it, projectile.
Yeah. Okay, this is I think should be called spaghettification. What did you call it?
Well, doesn't go that far, but yes, it will. Actually, from the outside, he'll actually never enter the inside of the black hole. He'll slow down as he gets close to the surface and appear to freeze, and then slowly he will fade out as he turns red. But you'll never actually see him go into the event horizon. But from his point of view, he will.
If time slows down that radically as you're going into a black hole, you'd never feel the spaghettification as you get stretched apart, would you?
Your perception of the time doesn't change.
Yeah. From the outside, we would not see him get spaghettified, but from his point of view, he would see it and feel it.
And
he would
then be
also
stuck
be
there.
able, if he looked back out, he would also be able to see all the galaxies start spinning and time passing and the universe evolve. And by the time he went into the black hole, the universe would be trillions of years old.
Well, it didn't take that long for Matthew McConaughey in Interstellar. His daughter only aged into old age back on Earth, right? Didn't he go through the damn black hole?
No,
Yeah.
he didn't go through it.
And
he didn't go through it?
He was near a massive object called Gargantua, was a neutron star or something, but it wasn't a black hole.
And he sent it somehow
Oh,
ended
was-
up on a planet.
I don't recall the plot that well, but he was quite a while beside a massive object, so time slowed down for him. So when he got back, his 10-year-old daughter, who begged him not to go, was a dying grandmother with generations of kids.
Well, I did reply to your reply to me, Mr. President, about what I tried to correct you on last Wednesday, but we won't bring it up now. I just, if you can
Okay.
find it, open it up. Aha, this one I don't remember. We're inside, obviously, an observatory. It's called work. Wake up. We've got 1 billion things to get to, somebody's saying in the first box.
A
And
billion
he's
to the power of 10 things to get to.
well, they don't look through telescopes like we do inside
I
observatories.
canceled my appointment for tomorrow. You received that email.
Says, I won't be home for dinner. The universe keeps expanding and we're understaffed.
Well,
Now,
actually,
this type of astronomy ended about 1900.
You got to mute, Bruce. You got to mute, Bruce.
There we go.
There you go. Thank you.
How would you know he was talking?
You didn't hear him?
I didn't hear him. I've just proved I don't exist. The scientist at the blackboard worked it out, and now he's very depressed. It doesn't look like Brian. That does not look like Brian Cox. I'm sorry.
No,
He's a pretty handsome. You know, he was an ex band member, heavy metal band, I think, or something.
That's not Cox. That's
He was a
it
band
was
member,
a member
wasn't
of Queen, Brian
No.
May.
he? Is that what it was?
Brian-
Queen?
Brian May.
Brian May.
My understanding was Brian Cox was in a rock group before he
I
decided.
I haven't heard of that. I don't know. Might be right.
He wasn't as famous as Brian May.
I've never heard of
doing that,
Brian
yeah.
May. Well, let's go to the hardcore stuff, gentlemen. Increase that, Mr. President, so we can read it. What are we doing here?
Oh, this is the weekly roundup of planets. Can you guys read it, or do I need to switch to another?
No, it's fine.
It's
Yeah.
great. It's
Okay.
good.
So Mercury is too close to the sun.
Mhm.
Venus and Saturn appear low in the eastern dawn as they, in the morning, they rise. So you got to get up really early to see them. Mars is in Cancer, which is high in the southwest in the evening, which means that it's going to set sometime around midnight. And Jupiter down here is in Taurus, shines low in the west. You will see it, and it'll set a few hours, sets around twilight's end. So when it gets really dark, that's when Jupiter is gone. And Uranus is hidden in conjunction with the sun, palling around with Mercury again. And Neptune, a mere 8th magnitude, lurks hidden in the dawn background of Saturn. So it's not good for evening viewing of the planets,
No.
but we'll get to that later, about 6 months from now. It'll be better.
Yeah.
Can I ask a
Mars
question?
is so-so.
Yeah,
Is it possible that one of these magazines where you get a lot of this astronomy or science telescope could show the solar system side on, not edgewise, but side on, where you look in from an angle and get a 3D version of where all the planets were?
yes, that stuff is readily available on the internet somewhere if you hunt for it, but it's not really illustrative of what you'd see from the Earth, because we can't get to the position where you'd see that.
Well, we see some planets on second Saturday star parties, and they're over us.
Yeah, yeah.
Well, just a question. I didn't know. I've never seen one.
Well, they had those diagrams in the magazines,
Yeah.
and you can easily get them, but they're as though you're hovering up over the sun, looking down on the solar system.
Well, for every two orbits of the Earth, Mars goes about one orbit.
Yeah.
Does the inner planets to us, Venus, take half the time in one of our orbits? Does it go
Take a
half a
fraction
bit?
of the time. I don't know if it's half.
It's 9 months for
Oh,
Venus
it's 9 months.
Yeah.
and 88 days for Mercury.
Okay. Well, I got it.
That's about 3 months.
Yeah.
So the idea that you can just decide when you're going to go to Mars like Elon seems to do. He's ignoring the fact that you can't choose to do that. You have to be at the right position to make the trip last only 8 months. Otherwise, it's going to take way more fuel than you can get on board one of those things. By the way, I think his 9th attempt at orbit is going to be sometime this week.
His ninth explosion.
With, yeah, the next Rudd.
Yeah.
Now this is a picture of Saturn's rings.
This is a generated image. It's not a picture.
Okay, well, this is a graphic.
Yeah.
Saturn's
Really?
rings. It's
They had to generate it based on something, didn't they?
Yeah, they based it on an actual Cassini image that doesn't look anything like this.
Yeah.
Oh, okay.
So, but this is from Cassini data, and this is the Saturn moon Daphnis. And I could not find a reputable citation for where this was or who generated it. So it is an AI generated thing. This is an actual image from Cassini that has been processed to get all the dust donuts out and stuff. This is not AI generated, but this is the data that other picture was probably generated from, because there's a lot of pictures of this going out to the side and stuff, different amounts, wide field views and short field. And you can
So
see
that is Daphnis there.
this is Daphnis. It's an
Oh my God.
elongated moon. It's not spherical like the other picture had it. And here are these waves that are seen. The fact that the wave bends out or in, I'm not aware of the data that shows that. So
Wasn't
It's
there,
what-
is this kind of referring to the spokes that they supposedly see
no,
on?
this is not the spokes. That's a different effect.
Oh, okay.
The spokes are not understood yet, to my knowledge. At least I don't understand them.
The spokes seem to be associated with the magnetic field of Saturn. And it's where you get you end up with like a static charge on the individual particles in the ring, and they rise up or lower down in
Yeah.
response to the magnetic field.
But it's a shepherd moon, right?
This is a shepherd moon here.
Do you
It
suppose
defines
the shepherd?
the edge of the ring.
Yeah.
You suppose those shepherd moons are made of all the stuff from the ring material that decided to coalesce and gravitate into a ball?
You can see there's a little funny line on Daphnis there that makes it look like a little dumpling. That's where it's accreting stuff from the rings onto its kind of like its equator.
So they were all created from stuff in the rings.
Or they may have started out as bigger chunks in the rings.
Right.
Got
Actually, it
captured
looks
in.
like a lifeboat from Oumuamua.
Why do you suppose it makes ripples like the edge of a doily there on
It's
the inner ring?
gravitational attraction.
They're moving at different speeds, and so these particles are feeling the gravitational pull toward Daphnis. But by the time they have to react straight up here, Daphnis has moved on. So then the thing starts feeling the gravitational field from the rest of the ring, and so it collapses back down. And as you look down the ring, they oscillate up and down as they are oscillating around their equilibrium position, which the next time around, Daphnis will disturb again.
And you
Saturn
can see it's
apparently-
pulling a little on the outer ring too.
Yeah, you can see a bulge here, and then it's going up.
Is
So that's
Daphnis
because-
an ancient Greek goddess or something from Shakespeare, you suppose?
No, it's one of the lovers of. Oh,
Right.
wait, I'm sorry. I'm mixing this up with Jupiter. Never mind.
Yeah,
I keep
Daphnis
thinking
and
of
Chloe.
Daphnis and Chloe, yeah,
Daphnis and Chloe.
yeah.
But
But
Saturn
anyway,
has more ring. What?
the outer ring is moving faster than this one. So here, this is moving this way, but this ring is moving this way faster.
Yeah,
And
Jerry,
that's-
just just an added thing. So if anybody wants to hear some absolutely incredible music about Daphnis and Chloe, Debussy.
yeah,
Yeah.
one of my favorites.
Oh God, is it beautiful?
Yeah,
Well, Bruce, can it be played on an organ?
anything can be played on an organ.
Yeah.
But Saturn, my understanding, Saturn has more moons than any other planet. Do they count these little shepherd moons
Yes.
among them? They do.
They haven't yet started counting the ring particles.
You're muted, Bruce. There you go.
Yeah, Bruce, we can't hear you if you answered me.
No, he's unmuted. He's fine.
Yeah, I said the organ is the largest musical instrument that's made, and it can play virtually anything, especially a theater pipe organ, which is designed to emulate the sounds of a whole orchestra.
Yeah, it can imitate almost any instrument. I don't think it can imitate a theremin, but we know. We'll see.
Or
No,
maybe.
we don't have things that slide around, but we do 7-tune percussions, and they're real.
Okay.
Marimba, glockenspiel, crucible, xylophone, chimes, piano.
So let me go back to this picture. This is one that I try to avoid saying anything that's AI generated, but Chuck caught this because I didn't find a citation for it. This one is not AI generated. The caption tells where it's from, but this is a very dramatic solar flare or prominence that's detached a little bit. You would easily see this in our solar scopes that we have if you were looked at it at the right time. The magnetic field lines come from around here. They go up in a big arc, and the material up here is cooling off, and so it's emitting light as it gets up and away from the sun's volume.
Oh,
Very,
Looks like
very
that.
dramatic image.
the hummingbird.
Yeah, hummingbird catching a mosquito.
Looks more like a kingfisher.
Yeah.
It looks like
Yep.
that too, but that would be a
Good point,
too hard
Chuck.
on the fish.
Yeah, that's a good bird idea on that one.
Yeah.
So these are flares.
No, those are prominences.
Prominences.
Now this is a
A flare would be like the bright marks on this view.
Yeah.
Flares reach us.
This is from a video, and I tried to capture it right as the flare was going off.
Oh,
And you can see it reflected stray light down the tube of the telescope. So this was, it did not aim at us, which is a good thing because this is a very powerful flare. It happened on May 14, which was what, 3 days ago, 4 days ago, 5 days ago. So, and it caused a lot of auroras on Earth, and it hit the Earth a glancing blow over India. So the U.S. was spared all the ionic impact, but the sun has been very active.
Yeah, it sure has.
yeah.
Did it cause any electrical problems in India?
I didn't look for that, but there was a map of where the largest impact was.
I think it caused a lot of shortwave radio outages.
Yeah, it screwed up.
Yeah, they're having more trouble with Pakistan.
Yeah.
Okay, now we're going to go into a series of things on galaxies. What is a galaxy? And it refers to any large system of stars, gas, dust, dark matter, all held together by their mutual gravity. And the report in Sky and Telescope was it's actually not a bad definition, except that not every galaxy has all these features. There are galaxies without any detectable gas and dust, some that seem to have little or no dark matter. The common thread seems to be that they all do have stars. But even then, we run into the trouble because not all gravitationally bound systems of stars rate as galaxies. And so the transition point between galaxy to globular cluster is what they're referring to.
It's just like the whole planet, dwarf planet thing.
As a matter of fact, yes. Then that, in my view, the astronomy is loaded with those kind of things. We have about bins we want to put things in to think about them, and nature doesn't know anything about those bins. So we've seen this
Didn't
before.
watch our program.
What's that?
Didn't watch this program. Nature.
Yeah, this is their second week on galaxies.
Yeah. So this is elliptical galaxies here. There are 4 major categories of galaxies. There's elliptical, spiral, irregular, and peculiar. I don't see a strong difference between irregular and peculiar, but we'll see. So a spiral galaxy can either have a true spiral or a barred spiral. Our galaxy is a barred spiral.
And they're all spinning in the same direction.
No, they're not. They're about 40% are spinning one way and 60 or 70% are spinning the other way.
This artist's conception has them spinning all the same way.
No,
No, there's no motion here. They would look either way. They would look like this, but they would spin either way.
Oh, okay.
the
There's
directions of the arms don't tell you much.
Yeah.
Okay.
As a matter
Really?
of fact, there was an article that I read, but I decided not to include it, but I'll talk about it for a second, that said that they surveyed galaxies and 70% of them are spinning one way and 30% are spinning the other way. And that people are taking off on that and saying, well, that means the whole universe might be spinning. But the fact of the matter is that survey was only done on 264 out of the trillions and trillions of galaxies that are out there. So it's a meaningless statistic. It's not anywhere near six sigma. So there's no indication we're spinning. Yes.
Can I ask you a question about something you just mentioned, and then maybe you'll be getting into this? You said some galaxies they've determined have no dark matter.
Yes.
Does that mean they're spinning their stars out into space?
No.
No,
It doesn't.
you look at what the velocity of the stars around the center. And if that velocity fits Newton's law or for gravity or Einstein's general relativity law, then it doesn't have any dark matter.
Do the ellipticals turn?
Not as an organized system.
Yeah, I think they're more like a beehive, like a globular cluster. But when I was young, we had an arrow going this way for evolution. But this is just a categorization. It doesn't mean that galaxies start here and end up as one of these or the other way. They're still trying to figure out if this means evolution.
Well, on May 2nd, earlier this month, our speaker from Berkeley, from inland, San Bernardino, was talking about dwarf galaxies.
Yes.
Are these little suckers, did I miss when she said they're set up just like these, or are they just blobs?
They tend to be more irregular.
Yeah, we'll get to those.
Oh, okay. Gotcha.
Okay. So this is a group in the Virgo cluster, this is a group called Macarian's chain. It's a chain of galaxies. And you can look at them and you can see certain of them are spirals edge on. There's a spiral edge on. This one seems to have some arms faintly. A lot of them are elliptical. M87 is the one that is an elliptical galaxy and it has a jet coming out of it, which you can't see here. And it's also the one where they image the black hole at the center of it.
It's like
So
the
Jerry,
500-pound gorilla.
So Jerry, if we were past those galaxies, 70% of them would be spinning the other way. from the vantage point we're at right now.
Yeah. If you look at them from the other side, they're going the other way.
I never thought of it that way, but yeah.
That's a good analogy.
I think the spinning is with respect to the arms, whether it looks like the arms are spinning up or spinning backwards, like
Okay.
drug.
Okay.
So
that is so hard to see. It just doesn't make sense.
it is counterintuitive, yes.
Boy, you
A
sure
lot
got
of
that
astronomy
right.
is like that.
This one's really blown out.
Okay.
Wow. Anybody know how many years it takes for our solar system to get around, make one complete
It's
circumference?
something like 220 million years or 250 million years.
Yeah, 250 is what I heard.
Well, it's about
Last time we were what is it? Last time we were here, dinosaurs roamed the earth.
Yeah.
wow. But isn't that about the same length of time it takes two galaxies to collide?
That's more like billions of years.
That's even longer then.
Get yourself a 6-pack of beer and sit out back and watch the Andromeda Galaxy collide with us.
Yeah, I was gonna say.
A lot of
You need a
DVDs.
So this is our galaxy, and this is a map, obviously, not an image. This is the bar, and this is right here where we are, the sun. And most of the things around here that are named are things that we can see in the night sky. We don't see things over here so much. We do see some things, but we have to look above or below the bulge of the galaxy. This is Sagittarius A star right there, which is not a star. It's Sagittarius A asterisk, and it means the black hole. That's how black holes are labeled.
And speaking of things we don't see on the other side, if you scroll this down a little bit, you'll see up above there, there's an arrow and it says zone of avoidance. And that's the area where we're trying to look through all the gas and dust of the galaxy. And it was called the zone of avoidance because we didn't see other galaxies there back when they thought that other galaxies were just condensations within our galaxy.
Right.
And they were wondering why they avoided that area of the sky.
So before 1927, many people considered this to be the entire universe.
None of our radio telescopes can even look through the bar to the other side, can they? They
Oh,
can
yeah.
see the.
That's
Can
how
they?
we mapped out these spiral arms.
Yeah. They do a
Well,
lot
radio-
better job of getting through things, but there's nothing that makes everything absolutely transparent. Now, this is a side view of our galaxy, and this is an actual photograph. It's a mosaic pieced together, and it's beautiful. Because we're in this, we're in the arm of this. There's the rest of the Milky Way goes around behind our heads. This is the central bulge, and in there is Sagittarius A star. And here you can see, go ahead.
If you printed this out on a piece of paper, you'd have to curl it around so the right and left edges met. And that would be our view.
Right.
Hmm.
Down here are the two Magellanic Cloud, two satellite dwarf galaxies. These are viewed in the southern horizon. This is the north celestial pole, which is in the constellation Virgo for us in the springtime. And down here, I believe this is Andromeda. Okay, let's go.
Andromeda's not in the southern hemisphere, so no, that looks like an
I was wondering
artifact.
about that, but I don't see anything else that could be
Yeah.
something.
Well, if
I have a picture very like this that shows the entire galaxy, and Andromeda does show up on it, but it's more in the left.
Yeah. Well, this
Upper
is
left.
Yeah, okay.
But if science finds any more black holes floating out there in our Milky Way galaxy, they're going to call them stars, aren't they?
No, there's lots of them, and they don't call them stars. They
Well, they
tend
call
to have a name like Sagittarius A because they're first found because they're radio sources and X-ray sources.
Yeah. Actually, on close examination, this looks like a star because it's
Yeah,
got diffraction spikes around it. So it's just
Yeah.
a nearby star.
Oh, there's Andromeda on the far left.
Oh, you're right. Yeah.
Interesting that it's showing kind of south.
Well, this is the galaxy north-south, not Earth north-south.
That's true. That's true.
This does go up, yeah.
We're at an angle, I think, yeah.
Now this, I got to go back to the other way of looking because this program thinks this is my last slide. As soon as I find what getting out of it is.
I sent you a picture in one of our past one of these past meetings of the largest small Magellanic Clouds that I took down in Outback in Australia, just with my camera on a tripod. It was
Yeah,
stunning.
I think we showed that. When you send me things, I always put them in if I can.
Yeah.
So now looking through these categories of things, starting with elliptical, this is a large elliptical galaxy. There is no structure seen here that could be attributed to definite arms. And this is, in fact, M87 with its...
The jet.
I'm not sure this is the jet. It looks like galaxies in the background.
Background galaxy, yeah.
Because the jet is very hard to get. You have to take a special photograph of it and then add it in. but it does have a jet. In the background, you can see other things edge on spiral galaxies. And this is a peculiar galaxy.
Highly processed.
This is very highly processed. There is a series of software programs that come out that are things that you plug in to the most popular astronomy software processing things for photographs, PixInsight. And they were generated about 2 years ago by an amateur who also is a professional processor, developer of software. And he developed 3 programs and he used AI to develop them. And I have those programs and they produce this really, looks like at first over processed, but it's really just bringing out a lot of detail that we've never seen before. The guy's name is Russ Croman, absolute genius at this stuff. He took several months and set up a learning program, and he gave it a picture of the best picture he could find of different objects. And then he blurred it, and he told the thing to learn how to get from the blurred to the process of a shark, for example. And these programs are just amazing. They're just taking over like a storm. They're called Blur Exterminator, Star Exterminator, and Noise Exterminator, and I'm learning how to use them. This is obviously one. This is a previous picture taken by Hubble that is an example of something that we would get without that heavy level of processing.
Plus, the other one looks like it might have had an overlay of ultraviolet or X-ray, and that was shown in the blue, in the bright blue.
It could be.
Yeah. And what's interesting about this one is these form when you get like a collision that's directly dead center, and it sends a shock wave symmetrically outward.
Yeah.
And in this case, and they form these ring galaxies. But in this case, there's another ring galaxy in the background, and that's that little reddish thing way far in there.
Yeah. So this looks like it was a consecutive drive-by collision. No, just joking.
Yeah.
There's
Yeah,
little
that other
galaxy
one's so
flying
far
over
in the
the-
background.
Yeah.
I don't
There's that little
understand why
galaxy,
collision.
Does a little galaxy gravitationally interact with what we're looking at?
No,
Or
I
is it
don't
too
think so.
far
It's
away?
far in the background.
Yeah.
Okay.
Yeah, the collision is what makes it get this weird shape, the ring.
Yeah.
Huh.
Because the densest part of the colliding galaxy hit directly the densest part of the target galaxy. And it blew things out. We discussed that about a year and a half ago, something.
Okay.
And, there's a number of these ring galaxies, and in most cases, there is a heavily distorted galaxy right on the axial line of this galaxy. Some galaxies don't have the remnants of the collision, but some do. And that's how they decided that that's what's going on here. Now, you'll notice that this other ring galaxy back here is red. This is red. This is red. So those things are far distant on this scale. Now, this is a star that's red, so it's probably red for a different reason.
Or probably a nebula like the Orion Nebula.
Or that. But this could be because of distance that these are red. So these are far away in the background.
There's another one called the Cartwheel Galaxy, too.
Oh, yes, that's very much like that. So this is our large and small Magellanic Cloud against the background of our Milky Way, which actually the foreground of our Milky Way, because these are all stars in our galaxy. We're looking out through our galaxy to see these. These are dwarf irregular galaxies. They do not have any discernible remnant of spiral arms.
But you can see there's a bar in the Large Magellanic Cloud.
Yeah, right.
Yeah, there's a bar. The arms may have been swept away. Just the bar is left.
And my photograph shows the bar much strongly because it isn't as overexposed as this for the middle of the Large Magellanic Cloud.
That's a good point you're alluding to, is that if you take pictures of these things, depending on how long the picture is, you can completely lose the sense of seeing a different picture because the background, there's so much in there that your eye doesn't put together the same patterns. In this, I see dark nebula, little streaks back here, going down there and up there and stuff. And we know these are little wisps and trails of neutral gas that is not activated by a hot star nearby to glow red or blue, whatever the ones it is for emission. And it's not being shown on and by reflected light from stars either. It's just out there all by its lonesome.
My camera has a feature, the Nikon D700, that it's called high dynamic range. And it takes two pictures and it combines them and it does an excellent job.
What camera is that?
Nikon D700.
Right.
This is a little blown out, but it's okay.
Want me to switch to the other one?
It's okay.
No.
Whatever the green stuff was in that one.
Gents, I'm going to have to leave you. I'm going to try to re-sign in again. I'm getting terrible static behind everything anybody says. For some reason, it started about halfway through. So I'm going to leave you and see if I can sign in again.
Okay, good luck. Is this better, Chuck?
That's much better.
Okay. This is a dwarf irregular galaxies, NGC 4214. It's about 10 million light years away. It's near us. So let's see, what does it say about that? This was taken with by NASA and European Space Agency with the Hubble Heritage.
Are these false colors then?
All pictures of stars are false colors.
Yeah.
But many people try, like I do, I bet when I do processing, and I'm sure you do the same thing in one form or another, Bruce, you white balance your various data inputs.
Oh, right.
By either some automatic thing in the camera or by the definitions of the filters you use, or by taking an image of a sun-like star, which defines white, is the way I do it. So you find a G2b star, which there are zillions of them out there, and you try to not take an overexposed image of it, and then you use that to balance the RGB layers.
You can do that afterwards using Photoshop too. You point to something and say that's white.
Yeah, I do that, yeah. I'm trying to switch over to PixInsight, but I noticed
That's how that works.
Learning something at 81 is a little longer than learning something at 21.
Well
That
said.
means I'm even slower yet.
Yeah.
So this is a dwarf irregular galaxy. Now this, what is this? Can you tell?
Globular.
Globular.
It is right on the border. This is the largest globular we have in the sky. This is, it's the southern one.
Omega Centauri?
Omega
Yeah,
Centauri,
that's it, Omega Centauri. It is mostly dwarf galaxies that appear to contain no dark matter. So I guess they've been whipped around too much by competing gravitational field, and the dark matter has decided, which is very responsible to magnetic or gravitational field, just went off some other way. So this looks to the naked eye. This is a globular you can easily see in the southern hemisphere with the naked eye. It looks like a star that you can't quite get to form a point in your eye. Oops.
The difference again between globulars and star clusters?
It's not
globular is a star cluster. It's just one of the two kinds, globulars and opens.
Okay, got it. And I don't know if I missed it, but could this be a captured dwarf galaxy?
There's speculation about that, yes. Now, when some of our globular clusters, actually all our globular clusters, exist in a ball, a sphere around our galaxy. They do not conform to the disk of our galaxy. So they're all around it in a sphere. And some of the things that the globular clusters, as they orbit, we get really clear views of them, but they're like a comet in the sense that they leave off behind through tidal forces from our galaxy. they're being stripped of stars. So they leave a slight and faint trail of stars behind them, and frequently one out ahead of them too, where stars have their own velocity with respect, or their own orbit with respect to our galaxy's core. So they are slowly disappearing, and they could have been a dwarf galaxy that's just too close, like the Magellanic Clouds, and they've been around so many times. They're closer than the Magellanic Clouds.
And what happens sometimes is, or most of the time with them, is they're so dense in the cores that the stars interact and stars get tossed out. But as stars get tossed out, the remaining stars end up closer together. So
Yeah.
even though they lose stars, they get denser. They appear denser when you look at them.
Do you suppose there might be stars stuck out there, thrown out of a galaxy in the middle of nowhere with nothing but a night sky full of galaxies?
Absolutely.
If you look out at tonight's night sky, there's Arcturus, and it's a star that's in a galactic orbit rather than in the disk. It's in a not perpendicular, but highly tilted orbit. So it's something that's more like a halo object than like the other stars around us that are parts of the arm.
Now, there are people, astronomers, that do modeling of our galaxy and Andromeda in 5 billion years from now when they pass through each other, and they want to see what's going to happen. Now, of course, these are not reliably predictive. They're statistically probably in the right ballpark. But several of these simulations have the Earth and its sun and our sun flung out of the resulting Milkomeda. So we would become one of those solar systems that's out there that doesn't have a home galaxy. But that's 5 billion years from now. And in 2.5 billion years, our sun will expand enough and burn the Earth up, so we won't really care about it.
But something that bothers me or confuses me is the tug of war between the Hubble constant, I believe that's the expansion thing, and dark energy pushing everything away, and yet things like Andromeda and others out there, other galaxies, are pulling together.
Gravity's stronger.
Is that what it is?
Yeah.
Yeah, gravity sucks.
Right. This globular cluster isn't dispersing that strongly because the mutual gravitational attraction is stronger than other things pulling on it. So if you get real close, the gravity wins. Now, yeah, I forgot. Okay.
Interesting.
Now this is a very nice spiral galaxy, NGC 3982, which is a true spiral, no bar. And you can see the red regions here, which are nebula, where there's star production going on. And these are young, hot blue stars that are scattering after they've been born in these nebula here. These are things like the Orion Nebula in our galaxy, where stars are being born. And then these are longer, older stars where there's not a lot of new stars being born.
So the red area is hydrogen rich, I gather.
Yeah. So, and that is the range and extent of things we call galaxies. Now, there's another one I didn't know about, which is called DDO 68. It's a dwarf galaxy. It's 40 million light years away in Leo, and it's classified as a galaxy. And this is it, taken by an amateur. But this is taken from Hubble data. You can go to a website called Hubble Mast, and in FITS format, you can download with a program that's free online called FITS Liberator. FITS is an acronym, I forget what for.
Flexible Interactive Transfer System or something like that.
Thank you. Yes. And so you can, and this guy did this, forget his name. Let's see. He does really good.
Is that
were,
Gendler?
John Bozeman.
Ah.
So he processed the masked portal data from things. And the cameras, when they put up a scientific instrument, they don't do RGB filters like we do when we're amateurs or setting it up, because we are trying to take basically pretty pictures. They're after scientific data, and so their filters do not correspond with our RGB. So the amateur that does this has to cobble together the channels as the way amateurs define them to get them to look like pretty pictures. And so this one, he did a red, green, and blue RGB, but he discusses the different cameras he used to approximate that, or the different channels he took from Hubble. And he used PixInsight in Photoshop. And then the next picture is that same object processed and photographed by the Hubble Space Telescope crew, and a little closer up.
Doesn't look anything like it, does it?
So I think it's rotated slightly.
Yeah.
Well, it's rotated about 45 degrees.
Those three, and no, maybe these are those three.
Those
But
are like
this-
background galaxies.
Yeah. So this is the dwarf galaxy, and it's very irregular.
Did Professor Wemberly bring this up on our first Friday meeting?
No, he didn't. This was something I stumbled across.
Gary,
what
why would this be classified as a galaxy and not just a large cluster?
I guess whatever suits your sense of aesthetics.
It's kind of isolated, and it's got billions of stars. So
So this is kind of it's not as small as a cluster. Then it's
Yeah.
just there's many clusters embedded in this.
Could be.
Yeah.
The reason this is of interest is we want to study the dust that's in the early universe of 13 billion years ago, but we can't see dustiness in that kind of situation. So they looked for things that are that look like what they consider previous galaxies would look like, producing dust. And so they're looking for metal poor. Early on, the stars were all hydrogen, so they were all metal poor. They were mostly made of hydrogen. So where did the dust come from? And so they're studying dust generation in nearby objects that the stars are primarily also metal poor for some reason. So that mimics what they think galaxies would look like a long time ago. So this is called an AGB star, which stands for asymptotic giant branch stars, which can produce significant dust, for example, in the Magellanic Cloud and the Milky Way. But it's unclear whether the production is as prolific in the metal poor stars that are representative of high redshift galaxies. So they're looking at this galaxy to see if it can produce the type of dust that we get normally. And they're labeling this as a early galaxy mimic.
So the metal poor galaxies don't produce dust?
That's what they're trying to, they don't see how a metal poor galaxy could produce dust, because dust in our galaxies is made out of the metals. So dust, hydrogen doesn't form a dust, so to speak. But hydrogen was the early universe predominant material, and they made very big stars, and they burned very hot, and their lives were very short. So even though they started metal poor, they could have produced copious amounts of dust, and they're trying to pin that down.
Yeah, Tim, when Jerry's saying metal, he means anything other than hydrogen and helium, not necessarily what we call metals.
Yeah.
Okay. I'm just beginning to understand what my closet's here at home.
Yeah.
But the part that is the galaxy is all the white, fluffy stuff.
And some of the pink.
Yeah.
Well, the bright blotches are stars in our galaxy, aren't they?
If
I-
they if
there's a
they've
lot of
got
those-
the crosshairs.
Yeah, these are a lot of, yeah, that's a star in our galaxy. But these
Got it.
rest of these things are galaxies. There's
And
another
you said,
star over there.
this dwarf galaxy had billions of stars?
No, I didn't say that.
No, it has
Oh,
at least a billion. That's one of the sort of benchmarks that people use.
Well, are
I
you
was saying that they're trying to study galaxies that are billions of years old.
oh,
But
maybe
they-
that's
But like they were at the beginning of the galaxy, or the beginning of the universe, and they have this one very close to our galaxy, and it appears to be metal poor stars. So they're trying to figure out how much dust metal poor stars can generate, because early on they considered that the stars were largely metal poor.
And again, anything that's metal poor is anything that doesn't have hydrogen or helium.
No,
Or
metal poor means only hydrogen and helium.
okay.
well, spectroscopy can make us learn whether it has higher elements or
Yes.
it's all hydrogen.
Right.
Yes.
So they're
So those
close up, you can take spectrograms of these individual stars, and you can see what they're made of.
it's all from former novas, supernovas, and hydrogen.
No. In this case, it would be more from primordial hydrogen.
Well, that's what I'm talking about. The metals only come from
Yeah.
explosions of stars.
Yes.
Metals are produced in hydrogen stars also.
Yeah.
But
But they have to be dispersed. It has to disperse out.
think about it. Oops,
But
what happened to my?
the Webb has not determined yet whether those 5 or 6 strange blobs that are 13 billion light years away they're not spirals. They look like irregulars, every one of them, don't they?
No, they're finding early spirals too, so that's part of the confusion. But that original 6 blob thing got overhyped, and some of those were just active black holes. So that whole thing about, we don't understand the universe kind of went away a little bit.
So we were looking at accretion disks. That's what we were looking at.
Yeah, basically. And jets.
The size of a galaxy.
No, you were looking at jets that were very energetic. So it looked like it was a lot of stars. Until they got a good spectrum of it.
Jerry, this looks like it's going to lead right into your the star formation or star life.
Yeah.
It's going to lead right into it.
2 minutes.
We got plenty of time.
All
So
right.
things in space that are spherical because gravity is trying to crush it down, but there are things that stop it from being crushed. And for our planet Earth, that is the resistance of metal. You can't, not metal, minerals. You can't crush dirt and rock. You can only do it so far. And then, but if you get it crushed enough, the temperature goes up inside and that makes it a star if there's enough mass, and fusion begins. But in low mass stars, and the things that resist the complete collapse of the star are in various physical effects that gravity crushes down to, and these are a list of those effects.
This is like a hierarchy of things that hold up against gravity.
Right. So the first one is electron degeneracy pressure, and that's what's holding our sun in, it's a plasma. It doesn't contain any atoms, it contains nuclei and electrons. And the electrons cannot be pushed completely together you can't crush electrons together because of the Pauli exclusion principle. And so there is a resistance force there. If you add enough mass to the star, then the star can overcome that electron degeneracy, and it will force all of the electrons into the protons. And there's a exclusion principle for proton or neutron degeneracy also. And that's where you get all the protons, all the electrons produce only neutrons. And that's where you get a neutron star. And those things are much smaller. They're about the size of a city on Earth. Now, as you go past the neutron star, we have quark stars, and of course we have black holes. The quark stars are believed to be produced, this is a hypothetical resistive process, for even higher mass. Some theories suggest that neutron degenerate pressure might not be enough, and the star could collapse into a quark matter state supported by quark generacy pressure. You can't push quarks into other quarks without more mass. And finally, the biggest mass is if the star exceeds the Tolman-Oppenheimer-Volkoff limit, roughly 2 to 3 solar masses for neutron stars, you get, if you pass up that, you then collapse into a black hole where gravity is so strong that it disappears within the event horizon. But I've seen very interesting speculation, and this is absolutely speculation, that inside the black hole, because physicists really have trouble with singularities, division by zero. So as the mass gets smaller and smaller, the radius of the mass goes to zero, and there must be something, a fundamental block on the actual singularity that keeps it from actually becoming a singularity. One physicist, I believe Brian Cox, has proposed that not only is the core of a black hole not a spatial point, it's a moment in time, because the black hole mixes space and time, but the material collapses so hard on itself that it bounces back into the black hole, but not out of the black hole, creating a Big Bang type event inside the black hole. And the black hole becomes then internally a new universe with a new set of physical parameters and laws. And what is that? Alpha is 1 over 137, the fine structure constant. So this would propose that black holes could contain a universe, and that we are inside possibly one of those universes in a black hole on the outside. So, and that's where all these discussions and speculations about a rotating universe would come from. But so far, absolutely no evidence to support that. And this is a pure speculation. There's no math to do this either. So this, as we've seen before, shows the life cycle of a star. You can start anywhere, but here you start with a nebula, dust cloud, globules, Bach globules, protostar. You get, then depending on the amount of mass, you get a brown dwarf, which never turns into a star. You start fusion, which makes a main sequence star, becomes a red dwarf, red giant, becomes a white dwarf, becomes a black dwarf, which our sun is going to do, or this thing blows up in a supernova if it has enough mass, becomes a neutron star, or becomes a black hole, depending on its mass.
Where is this from, Jerry? This is nice.
I could have to go look.
Okay.
Now this is in M1 and the Crab Nebula, and it's the showing the effects of a neutron star with these rings around here. And let's see, where's the other one? Oh, and this is from a pulsar, a rapidly spinning magnetar, a neutron star with a strong magnetic field and rapidly spinning. This is, let's see if we know where this is.
And that's what the M1 is, the pulsar in M1.
Yeah, yeah. So this red region here is around it's the waves bouncing off everything, a pulsar. And it's believed that pulsars are the source of the magnetic or the microwave pulses that we see, rapid microwave, something or other pulse, RMPs. Okay.
Oh, Ronnie left.
Oh, that's right. He didn't come back.
He did come back briefly.
Yeah.
Oh. Oh, that's why it's so silent. Okay.
Sam, you can grab any of the things that are up on the screen with the screen capture.
Yeah.
Alt print screen, and then you open Paint, and you can save it there, and then it's a file, and you put it wherever you want.
Oh,
Yes, I get all my pictures from donors like Bruce or myself or Chuck, or I get it from different websites. And some websites are very nice about offering a format that you can easily download, as long as, and then a little reminder comes up that you need to cite the source, which I do, if I can. And then some people are real nasty about it. They want me to pay for it. Oh God, who thought of that? And so I just screen capture, but I still give the source if I can. So, because several times I found very interesting things that are just bullshit. And so I leave that out, or try to. I don't think I've made too many errors along that. Well, that's it for today, folks.
thank you. Thank you very much.
Yeah, thanks everybody.
See you
I don't
next
know where
week.
Ronnie went, but bye, Ronnie.